Hey everyone, today we'll be solving LeetCode problem number 1481. Least number of unique integers after k removal. In this problem, we will be given an integer array and an integer k. And what we have to do is, we have to find the least number of unique integers after removing exactly k elements from this array. Okay, so let's try to understand it using this example. Here this nums array is given to us. It's an integer array and the value of k is also given, and we have to remove k elements from this array such that after k removal the number of unique elements are the minimum. Let's check presently how many unique elements are there. We have 4, 3, 1 and 2. Currently we are having 4 unique elements in this, and I can only remove k elements from this array. What I was thinking here is that if I remove the element with the least number of frequency, so let's say here 4 is having frequency 1, 2 is having frequency 1. So if I try to remove these elements with the least number of frequency, so I will utilize my k in a smaller quantity. So if I remove 4, the k value will be reduced to 2. If I remove 2, k value will be reduced to 1 further. And for the 1, I can remove any element, either whether 3 or 2, 3 or 1, because both the elements are having frequency more than the current k value. Okay, so if I think in this manner, like removing the element with the least frequency, let's say 4 I have removed, 2 I have removed, the remaining array is 1, 1, 3, and let's say I have removed this 3 as well. So this will be the remaining array. The number of unique element will be 2. Or let's say if I am removing all the elements randomly, let's say I have removed 4, 3, 1. These 3 elements I have removed. So the remaining element are having 1, 3 and 2. 3 number of unique element. That is greater than 2. So it's clear to us that we have to think in terms of greedy, that try to remove the elements which are having least frequency. So it's clear that we have to capture the frequency map. And if I prepare the frequency map, we have 3 times 3, 2 times 1 and 4 and 2. 3 is coming 3 times, 4 is coming 1 time, 1 is coming 2 times, and 2 is also coming 1 time. So this is the frequency map of the given array. And now using this frequency map, what I'm going to do is I will be following my approach, removing the elements which are having least frequency. And the current value of k is 3. So I can remove this one and the k value will be reduced to 2. And I can remove this one as well. The k value will be reduced to 1. And the 1 I can remove from any element. So ultimately the answer will going to have 2 unique elements. So to get the access of the least frequency first, I need to sort the values. So if I sort the values of this map, I will be getting 1, 1, 2, 3. So these are the frequencies. So from these frequencies, I can remove till k values. It means one element is coming 1 time, the another element is coming 1 time, third element is coming 2 times, fourth element is coming 3 times. So element which are coming 1 time, this element we can remove, this element we can remove, and one element from this we can remove. So ultimately we will be having 2 unique elements in the answer. So now it's clear to us that we have to sort our frequency frequency values. And then once the values are sorted, we can iterate over it and do the logic, like keep removing the frequency till k is greater than 0. So ultimately we will be having our remaining elements. Let's make a perfect dry run over this example. Here, using these numbers, we have captured the frequency map. This is our first step to do. After that, we have sorted our frequency map. This is 1, 1, 2, 3. It means we have 4 elements, 1, 2, 3, 4. And I will try to see how many elements I can remove within this k value. K value is 3. So our eye is on the first element. Whether can I remove this element or not? This value is 1. And 1 is already, the k value is already greater than 1. It means I can remove it and k value will be updated to 2. I is coming here. The value is 1. the frequency of this element is also 1. So this element whole I can remove. Yeah, if I remove this element as well, the k value will be updated to 1. Now I value is coming to here, and now I will see whether I can remove this element or not. This element is having a frequency of 2. K value is 1. So it means only one instance we can remove. We cannot remove it wholly from this array. So it means that only one instance we will be able to remove, and otherwise we cannot do anything. So in total, how many unique element we were having? We were having 4 unique element, like the number of entries in the map or the size of this frequency array. So 4 element we were having in the array initially, and now I is pointing to this element. It means, so element left side of this, so these two elements are already removed. So I value is 0 1 2. So this I value I can directly remove from this 2. 4 unique elements were present initially, minus I. This is the number of unique remaining element in the array. So this will be our answer, and we can directly return this value. Okay, now I hope this is clear to you. Let's have a look on the time and space complexity. For the time complexity, in our first step we captured the frequency map, and in the second step we sorted our values in the map. So to store it in the frequency map, on space we took and then stored it in the frequency map. After that, for the values, we sorted the value in the log of n log n time, and then we iterated over it and see how many element we can remove in the order of n. So ultimately it is going to be order of n log n time, and for the space we are taking our hash map. So maximum space will go till order of n. So this is the time and space complexity for this approach. Let's code this problem first, and then we will see whether we can improve this frequency further or not. Here first of all we will capture the frequency of each element in the array. If it is not present in the map, I will be just taking the default value as 0. Now I will be capturing the frequencies of each element in a separate list of frequencies, new array list, map.value. Now I have sorted the frequencies in the increasing order. Here comes the main logic. From starting I equal to 0 to I less than frequencies dot size I plus plus. And now I will keep on capturing the removed elements. So removed elements in the starting is 0, and now I will see removed element is equal to frequencies dot get I. So let's say I have removed element with the starting frequency, and the frequencies are already in the increasing order. Let's say at any moment these removed element are passing the k value. So let's say if removed is greater than k, it means that current instance is not completely removed. So let's say we were having 1 1 and 2 and 3 as the frequency, and the k value was 3. So initially my removed element is 1. So it means I have removed the first element. Removed will be updated to 2, and then remove will be updated to 4. It means this third element is not completely removed. It means all the elements left to this are removed. So what I will be returning is the total number of unique element we were having already. That is equal to the frequencies dot size. Frequencies element are storing the total number of unique element. Total number of unique element minus the number left side of the I value. I value is 2, so it means element to the left side are also 2. So I can directly subtract the I value from here. Okay, and if we are not able to remove any element, we'll just directly return 0. Okay, let's try to test our sample test cases. I comma 0. Sample test cases are passed. Submitting the problem, it goes submitted successfully, but the interviewer can ask you a follow-up question to improve the time to this solution, because we have taken a time of order of n log n to solve this problem, because we are sorting the frequencies array here. So let's try to understand a better approach where we are using counting sort. to not sorting these frequencies explicitly. Let's have a look on our different approach. In the previous approach, we solved it in the order of n log n time because we were sorting our frequency values. But in the interviews, we can be asked a follow-up question to reduce the time of this solution. So for that, we have an approach using counting sort, or you can say hashing. Let's take a same example. Here, this is the nums and this is the k. So what we did in the previous approach, we captured the hash map. First step was capture the frequency map. So 4 is coming one time, 3 is coming 3 time, 1 is coming 2 time, and 2 is coming one time. So this is the frequency map we have captured. And in the second step, what we did is we sorted these frequency values. So 1, 1, 2, 3. We extracted the values and then sorted it. So this sorting took an order of n log n time. That is taking our time. And now if we have a look on the constraints, that element value will go till 10 power 9. But the num size will go till 10 power 5. So how many time any element can come in this array? So that can be maximum of 10 power 5. So if we are capturing frequency of each element, what is the range of that frequency? From 1 to 10 power 5. And this value we can easily accumulate in an array, because ultimately we are capturing the frequencies and I want those frequency in the sorted form. So, and these frequency value will go from 1 to 10 power 5. So if I take an array, or if I directly use hashing, or you can say counting sort, 0, 1, 2, 3, 4, 5, these indices will behave like a key and the array will store the value, and I'm going to store the frequency map frequency map of these frequency we have captured in the first step. So here 4 frequency is coming one time. Okay, that is fine. No, sorry, the 4 is coming one time, 2 is coming one time. It means the frequency 1 is coming 2 time, and so that is done. Frequency 3 is coming one time, that is done, and frequency 2 is also coming one time. Okay, now all of these 4 items are done. Let me also ask you a question. How many unique elements we are currently having in this array? The map size is equal to the total number of unique elements. So currently we are having 4 unique elements, and these frequencies are in the sorted order form. So what we decided in our previous approach, that we will be removing the elements as per their frequency. So here we have 2 elements with one frequency. So we will try to remove these elements first, and then these elements, then these elements. So now value of k is 3, and we will try to remove as much any element we can do. So there is 2 elements with frequency 1. So can we remove these elements? Yeah, definitely. 2 element with one frequency. Total how many removals are required? 2, which is less than 3. So we can easily remove this whole elements. What is the value stored in the array? Was 2. It means 2 unique element we had already removed. Ultimately we were having 4 unique element, which is the map size, minus 2. 2 unique element we removed with frequency 1. For the frequency 2, how many unique element we can remove? Now the remaining value of k is 1, and the frequency of each element is 2. So we cannot remove any of the element. So now we cannot do anything. So even if from this element, let's say any element it is, its frequency is 2 in the starting, and now I am left with one removal. So even if I remove 1 from it, let's say it is 4 4. Even if I remove 1 4, there will be 1 4 already present in it. So the number of unique element won't be affected. Total number of unique element remaining is 4 minus 2, which is 2. So 2 is going to be our answer. So here the total ultimately the approach is same, but instead of sorting it explicitly using n log n time, we are directly using the counting sort, or you can say we are using the hashing to save our time to sort the frequency values. So what is the time and space complexity here? Let's discuss those as well. What is time and space complexity? So for the time complexity, we took order of n time to prepare our map and then prepare our hash. Ultimately, it is taking order of n time. And what is the space? Order of n space. So the time has been improved from order of n log n to order of n. So this is the major improvement using counting sort. And how I got the idea? By looking at the constraint. So you should always look for the constraints given to you. Otherwise, it won't be easy to figure out that we can use the counting sort instead of sorting the frequencies. And this question has been asked in JPMorgan, Amazon, and Booking.com. Let's implement our second approach. First of all, we are going to do the same thing. We'll be capturing the frequencies. Let's also capture the size of the array. Here we have captured the frequency. Now we will be capturing the total number of unique element we are currently having. That is equal to map.size. So these are the unique element we are currently having. Here to sort the frequency, I'm not directly going to sort it. I will be using the collection sort, or sorry, counting sort, or you can directly say I will be using hashing to store the frequencies. Int is an array. Let's say count of frequencies is equal to new int I plus 1. Not the I plus 1, it is n plus 1. N is the size of array, because array in the worst case any element can have the whole array occupied, so the maximum frequency will be equal to the n, and we have to store that n as well, so that's why the count of frequency size is going to till n plus 1. Now let's store the frequency in the count of frequencies. So for int count in the values, map dot values. So these are my frequencies that I'm going to capture. So count of frequencies, count plus plus. Now the hashing value is prepared. I will be iterating over every frequency. Frequency is going to start from 1 to going till n I plus plus. If the frequency is 0, we don't have to do anything. Let's write that check as well. If the count of frequency I equal to 0, in that case just directly continue. Now we will see how many elements we can remove. At one index the value stored is 2. It means there are 2 elements with frequency equal to 1. So either I can remove all the elements, or I will be removing some of the element from it, or there can be the case where I can only remove one element with one frequency, not the whole. So either I can remove either I can remove 2. 2 is the 2 number of element with one frequency, or I will be able to remove any subset. So for that I can directly divide k with I. I is the frequency and k is the total number of removal we are currently having. Okay, so here at this moment I need to see like how many elements of this frequency I can remove. So either I can remove all the elements, or k divided by I will get the component uh, that I will be able to remove. So for that let's take another variable int elements to remove. That will be equal to math dot minimum. Either I will be able to remove all the elements of frequency I, that is this value, or k divided by I. So I got the elements that these element I can remove, and now I will update the k value accordingly, that these number of elements I have removed of frequency I. So totally how many removals are required? The total number of unique elements removed into their frequencies. So this will be the updated value of k, and also the unique elements will be decremented. Unique elements, so unique element minus equal to elements to remove. Elements I have already removed from it. Okay, So now if k value is less than I, if k value is less than I, that is from the previous call we kept on removing the value, reducing the value of k. Now we are at this moment where we are not able to remove any of the single element of this frequency. In that case, we can directly return our remaining unique elements. Let's say as per our problem statement in this example, initially we were having 4 unique elements, and then we were able to remove all the elements with frequency 1, and for the frequency 2 we are not able to remove any element. So we will close this iteration here, and then if that is not the case, we are going to return 0. Okay, let's try to test our sample test cases. It's submitted successfully. Here what I did is as we are using hashing, so we don't have to explicitly sort our values, so that's why the time complexity is going in the order of n instead of n log n. Okay, hope you understood the problem. Thank you guys.